Welcome to Chapter 3. This is Lesson 3-1 from the Algebra Readiness textbook. Take out your new notes packet and a sharpened pencil so you're ready for the lesson. Today's learning target is to review place value and rounding of numbers, and also to learn various strategies for estimation. Let's start with a review of our decimal place value chart. This is our decimal place value chart. Notice it starts here with the decimal point. To the left of the decimal point, we have the ones, tens, hundreds, thousands, 10,000s, 100,000s, and millions places. Then to the right of the decimal, we have the tenths, hundredths, thousandths, 10,000s, 100,000s, and millions. There is a number written right below each of these. Here's our number. This number is read 3,684 and, notice where the decimal point is, that's where you say and, 26 hundredths. All of the digits after the decimal are read as one number, 26, and then the place value of the last digit is what you say at the end, 26 hundredths. Knowing the place value is important because we're going to be asking you to round to a specific place value, and so you need to make sure you're able to do that. Let's review how you learn to round. Rounding decimals refers to changing the value of the decimal number to the nearest whole number, tenth, hundredth, thousandths, whatever. So, how do we round? If we were asked to round 12 and 675 thousandths to the nearest tenths place, the first thing I would need to do is identify the number I need to round. In this case, the number in the tenths place is the 6. To round the 6, I look to the neighboring number to the right. That is the 7. If the 7 is 5 or bigger, I round my 6 up. If the number to the right is less than 5, I keep the number the same and change the remaining numbers to 0. Let's see what it looks like. You will see that in this number, I looked to the 7. That number is greater than 5, so I round it up and change the 6 to the 7. The remaining digits are zeros. So, in summary, 12 and 675 thousandths rounded to the nearest tenth place is 12 and 7 tenths. Let's practice. Identify the underlined place value, then round each number to that place. The first one, 38 and 41 hundredths. The number that's underlined is the 4 digit. That digit is the first place after the decimal point. If you need to refer back to this chart, go ahead and do so. The number that is immediately to the right of the decimal point is the tenths place. So I write tenths. If I'm going to round to the nearest tenths place, I look to the place to the right, which is the 1. The 1 is not 5 or bigger, so I keep the 4 the same and change the remaining numbers to 0. 38 and 4 tenths. I'd like you to pause the video now and work the remaining 5 problems. When you are done, come back and compare your answers to mine. Pause the video now. Hopefully you've had a chance to do all of these. B, the underlined value is the ones place. When I round it, I get 1. In C, the underlined value is the tenths place, and 7,098 and 6 tenths is my rounded value. D, the underlined value is in the thousandths place, 274 and 943 10,000ths. Nope, thousandths. I said that wrong. 943 thousandths. My bad. E, that the 0 is in the tenths place. Now notice that I did write the 0 here, and I wrote it because it asked me to round to the tenths place, so I'm showing what's in the tenths place, even though it doesn't really matter. It means the same thing to just write 5. And then in F, the underlined 5 is in the hundredths place, 9 and 85 hundredths. Moving on, how does this affect the real world? Some real world problems require only an estimate for an answer. Others require an exact answer. Decide whether each situation needs an estimate or an exact answer. And then explain. Number 1, a headline noting the number of people living in China. Because the number of people living in China is such a large and ever-changing number, that would be best to use as an estimate. Number 2, the amount of money a babysitter charges per hour. In that case, you would want an exact number because the babysitter will want the exact amount that she is owed or he is owed. Number 3, the width of a window screen. Well, someday when you are a homeowner, you will know that you would like that to be the exact width because otherwise the screen won't fit snugly. You don't want it to fall out. Number 4, the distance from the Earth to the Moon. When it's an exceptionally large value, like in question 1 where we're talking about the population of China, or the distance from the Earth to the Moon, estimates are usually best. Number 5, the number of hours at soccer practice in 1 month. Because the number of hours can fluctuate, an estimate would be the best amount. Number 6, the number of tickets to sell for a play. Because the number of tickets corresponds to the number of seats, you would want that to be the exact amount because you don't want to sell a ticket for a seat that doesn't exist. That wouldn't make your patrons very happy. All right, we are going to learn 2 methods to estimate. Originally, we were going to learn 3, and there are 3 in your textbook. But one of the methods is not used very often at all. In fact, I don't think I've ever used it outside of math class. And it's also not a 7th grade standard. So we are going to stick to the 2 methods that really matter. Let's go over them. The first method is to round all of the numbers to the same place. Please write this example in your notes. Now, in this example, we could round all of these to the nearest whole number. The whole number is the nearest ones place. So to round these, I would round the first number to 9 and the second number to 2. 9 plus 2 is 11. So when I actually solve 8 and 974 thousandths plus 2 and 154 thousandths, I will know I'm right if I get a number that is almost or close to 11. It's a good way to check that you've done your math correctly. Notice I use this little squiggly sign for equals, and that is almost equal to. It's indicating that that is an estimate. The second one that's in your that's in your notes, and I would like you to cross it off, is front-end estimation. And instead, I want you to write, with all of these questions, that you are going to round to the tenths place. So on your homework also, if you have a problem that says use front-end estimation, let's agree that we will round them all to the tenths place. Also, I want to reassure you at this time that you will not have any of those questions on your quiz or on your test. All right, so using this method of rounding everything to the tenths place, that is the 5 in the first number. So 38 and 6 tenths plus, 15 and 3 tenths. And I like to stack them. 9, 13, 53, and 9 tenths. The third method that we're going to learn is clustering. Now, clustering is used quite a bit, and it's the quickest method. A lot of times you'll use clustering because you can do it in your head. In clustering, you pick the closest number to all of the terms, and then multiply by that amount of terms. Let's see. Let's put this one in action so you can see. Here's your example to write in your notes. When I look at the number 81 and 75 hundredths, 79 and 56 hundredths, and 80 and 89 hundredths, I try to find one number that all three numbers are close to. I'm going to choose the number 80. Now I could take 80 plus 80 plus 80. Notice they're always the same number. Or I could take 3 times 80. 3 times 80 in my head is very quick, and I get 240. These numbers, the three numbers that are typed in the problem, all cluster around 80. And so that's why 80 is a good number to pick. Now, what is the point of estimating? The point of estimating is to check to see if your answer is reasonable, whether that's in a math class or if you're out shopping or receiving change when you go through the drive-thru at a fast food restaurant. It's important that you can anticipate approximately the amount of money you should pay or receive. This is just a fast way to double check that the other person's math has been done correctly, or that your own has been done correctly if it's your own problem. So, for example, take a look at this one. Estimate to find whether the answer is reasonable. Well, here is the original problem. $135.95, $15.90, $24.05, and when I added that all together, I got $275.90. But when using estimation, notice I drew a little think bubble around there because this is what's going on in your brain. So in your brain, you say, well, 135 is close to 140, $15.90 is close to 20, $24.05 is close to 20. I can easily add those three in my head and I get about $180. If my total calculation is not close to $180, then my answer is not reasonable and I need to redo my math. In this case, this is not reasonable. I did something wrong and I need to go back and fix it. Check the next example. The calculation shown is $464.90 minus $125.73. I get $339.17. When estimating to check, I see that that's close to 460. The next number is close to 130. Doing that math in my head, I get about $330. I see that 330 is close to $339.17. So I feel pretty confident that I did my math correctly and that that's a reasonable answer. Now, you try. We're going to estimate each of these answers, but we're not actually going to solve them. Estimate each of the answers by rounding. Pause the video and come on back when you're ready to compare your answer. When I was doing this problem, I've decided to round to the nearest whole number. 355 plus 205, and when I add those together, I get 560. Yes, that's right. 560. So I know when I actually do my math, I should get a number close to 560 if I did it correctly. Letter B. Let's round this one to the nearest tens place. That would be 450 minus 230, and I get 220. So when I actually do this problem up here, if I don't get a number close to 220, I know I need to go revisit it. Double check my math. All right, let's say you're going out to the grocery store. Carrots were $2.71, peppers were $1.73, and broccoli was $1.10. Estimate the total cost of the vegetables. All right, in doing this, you might round to the nearest whole number, and you would get carrots being $3, peppers being $2, broccoli being $1. So if my total isn't around $6, I better recheck the math of the cashier. All right, here's another example of real-world estimating. Estimate the total long-distance charge for the months of May, June, July, and August shown at the right. Now, my phone bill or cell phone bill is the same, or long-distance bill, is the same, relatively close in value every month. When I look at these numbers, 1535, 1605, 1490, and 1505, they're all very close together. They're clustered. So what number are they close to? To me, they're all close to $15. And there are 4 bills. 4 times 15 is about $60 total. Now you try. Try using clustering. Pick what number, there's only going to be one number total for A that 450, 520, and 555 are close to. Then B, there are those 5 numbers are all clustered around one number. What number would you say that is, and estimate the answer? And number A, or number 4A, all 3 numbers are close to 5. 3 times 5 is approximately $15, would be a good sum. In 4B, these values are all close to 25. 5 times 25 is close to 125. So when I do this math for real, it had better be close to 125, or I'd have to revisit my math. All right, let's practice on our homework assignment. Page 130, numbers 5 through 27.